In this video, we're going to talk about parallel lines and transversals, and we'll talk about the different types of angles that are formed when you have parallel lines and a transversal. Okay, so to begin, we're going to talk about what are parallel lines, and we're going to talk about what is a transversal. Okay, so parallel lines are what are called coplanar lines. I'll talk about what that means in a second. They are coplanar lines that do not intersect. Do not intersect. So first of all, coplanar means that they're what's called on the same plane. So like a plane is just a flat surface. So if you have a flat surface and you draw two lines that do not intersect on that flat surface, like a piece of paper or a marker board, or if you have two lines on a desk or whatever, they would be called coplanar because they're on the same flat surface. And if they do not intersect, no matter how far you extend them, then you could call them parallel. Okay, so parallel lines, it does have a symbol. So to mark that two lines are parallel, you could put, it kind of looks like parallel lines. It's just two vertical parallel lines. So that's the symbol to show that two things are parallel. Okay, and in a picture, if you're trying to show, like let's say that you draw two lines, and you know we're human, so we may not be able to draw them perfectly parallel, but to let people know that you're wanting them to be parallel, what you do in the picture is you put arrows going in the same direction. So however, like if I put one arrow here, I have to put one arrow there. If I put like two arrows, then I have to put two arrows. But to show, you just draw arrows on your lines. And so if I see that in your picture, then I know that you mean for those two lines to be parallel. Okay, and so if we name the lines, so let's say that this is line L and this is line M, then to show that in like using our symbols, you could say line L is parallel to line M. Okay, so that's how you show parallel lines. Okay, and so parallel lines, they could go sideways, they could go horizontally, they can go vertically, just as long as they do not intersect. However far you extend them, they would be called parallel. Okay, now a transversal is a line that intersects two coplanar lines at two distinct points. So we'll talk about this. Two distinct points. Now that's a very fancy way of describing this, but it's always good practice to kind of use some of our formal terminology. So transversal is a line that's going to intersect, meaning cross, two other lines that are maybe drawn on like a piece of paper. Okay, we talked about what it means to be coplanar, and it's going to cross them at 2 points. So for instance, if we had some parallel lines, so if we had a couple parallel lines, and remember to show that they're parallel, you put the same number of arrows. If I draw a line that crosses those two lines, so I'm going to just draw a line that crosses those, that line would be called a transversal. Okay, so this line right here, I'll put a T, would be called a transversal because it intersects those two lines at two different points. That's kind of what distinct means. Okay, so it could look like that, and T would be the transversal. So T in that problem would be the transversal, but it doesn't necessarily have to intersect parallel lines. You could just have two random lines drawn, and if you draw a line that goes through them, that would be called a transversal. Okay, so that is a transversal. What we're talking about today is different angles that are formed when you have parallel lines and a transversal going through them. So we're going to actually concentrate on pictures that look like this today. Okay, when you have parallel lines that are being crossed by transversal. Okay, So the first thing that we need to talk about are what are the different types of angles that you're going to see. And then after that, we're going to talk about what you actually need to know about those angles. Okay, so one type of angle that's formed when parallel lines are intersected by a transversal. So notice I drew some parallel lines, and I'm going to actually show that they're parallel by drawing my arrows that we talked about. So notice I have parallel lines, and then I have a line going through them. This line right here would be called your transversal, and then these are your parallel lines, okay? One type of angle that you could have is what are called corresponding angles, all right? So the way that you can kind of think about corresponding angles are these. Oh, my camera fell, I'm sorry. So these are the angles that are kind of like in the same spot, or sometimes you could call them your matching angles. So your corresponding angles are the angles that are in the same spot, and you'll see what I mean in a second, that are in the same spot. Or you can think of it as like what are called matching angles. Matching angles. Okay, so if you look at your lines here, whenever you have this transversal, like for instance crossing this line right here, there's 4 different angles that kind of come about. You've got this angle right here, which is angle 1, you've got angle 2, angle 4, and angle 3. And then if you look down here, it's kind of the same scenario with where this line crosses down here, you've got 4 different angles that are formed, okay? And so the corresponding angles are when you're looking from one set of angles to the other one. So like some of these angles will match up with other ones. So like if you look, for instance, at angle 1, and you look at it kind of compared to this group, it's kind of in the upper left corner of this group of angles. And so if you look down here, the one that's kind of in the upper left corner would be the corresponding angle with it. So notice angle 1 kind of matches up with angle 5 because they're both in kind of the same spot, just in a different set of angles, okay? So angle 1 and angle 5, angle 1 and angle 5 would be what's called corresponding angles. And then kind of the same thing, if you notice angle 2 is kind of in the upper right corner of this set of angles, and then the angle that kind of matches with that would be angle 6. So you would say angle 2 and angle 6 are corresponding angles. And then you could keep going. So like angle 3 would kind of match up with 7. So angle 3 and angle 7 are corresponding angles. And then angle 4 and angle 8 would also kind of be matching or corresponding angles. So that's one set of angles that you will have in these problems. Some other angles that we'll be talking about are what are called alternate angles or same side angles. So alternate and same side deal with the transversal, okay? So notice you got your transversal here. To say that 2 angles are alternate angles, these are going to be the angles that are on opposite sides of the transversal. So you've got some angles on one side. The angles that are on the other side of the transversal would be called alternate. So they're on opposite sides of the transversal. And then same side angles, these are the ones that are obviously on the same side as of the transversal. So same side of the transversal. Same side of the transversal. So with these, you're just looking at the transversal. All right. So just to kind of look at that, notice if you look at, here's my transversal. 1, 3, 5, and 7 are all on kind of the left side of the transversal, and then 2, 4, 6, and 8 are on the other side. So 1, 3, 5, and 7 would be called same side angles. Same thing, 2, 4, 6, and 8 are all kind of the same side angles. And then alternate would be the ones that are opposite each other. So like 1 and 4 are opposite each other because they're on opposite sides. Or like 1 and 8 are alternate of each other because they're on opposite sides of the transversal, okay? So that's one another couple terms that you will hear, okay? Something else that you're going to hear are what are called interior and exterior angles. So interior and exterior actually deal with the parallel lines. So to be interior angles, you're looking for the angles that are actually inside the parallel lines. So these are going to be inside the parallel lines. So I actually like to think of my parallel lines as like a sandwich. And so if I closed my parallel line, so if you look, there it is, here's my bread of my sandwich. If you think of them like a bread of a sandwich, if I close my sandwich, think about which angles would be closed in there. And so those would be your interior angles. So like if I look inside my parallel lines, angle 3, 4, 5, and 6 would be inside my sandwich if I closed them. Those would be called interior. Okay, so then your exterior ones will be the ones that are outside of your parallel lines. Outside of the parallel lines. So then these would be the ones that would kind of be outside of your sandwich if you think about it that way. So here's my parallel lines. These are the ones inside. So then 1, 2, 7, and 8 would be my outside angles. So those would be called exterior angles. Okay, so now that you kind of know about the angles, we're going to talk about what you have to know about certain types of angles. And these are the properties of your parallel lines. Okay, so these are the ones that you will definitely need to get in your brain so that you can just pull them out when you need to work problems. Okay, so anytime that you see two parallel lines and it's being intersected by a transversal, so there's a line going through them, then you will have these types of angles, and you will hopefully remember what we talk about with those angles. So the first one we're going to talk about is what happens when you have corresponding angles. Well, remember our corresponding angles are kind of like the 2 and the 6, the 4 and the 8, the 1 and the 5, the 3 and the 7. So what do you know about those? Well, if these were parallel, so I'm going to put the little symbol to mean they're parallel, then the corresponding angles are actually going to be congruent. So whatever the measure of one of those angles are, the angle that matches up with it will be congruent. So that, remember from our other video, this means that they're equal. So that means not only does 1 and 5 match up, but whatever the measure of angle 1 is will actually be the exact same thing as the measure of angle 5. Okay, same thing, angle 3 and angle 7 will be congruent. So like another way you could write that is you could say angle 3 is congruent to angle 7. So whatever the measure of angle 3 is will be the exact same for angle 7. And then same thing, angle 2 will be congruent to angle 6 because they match up. And then angle 4 will be congruent to angle 8. Okay, and so if you know one of these measures, the one that matches up with it will be the exact same measure. Okay, so some other things you need to know about certain types of angles is what happens, or what do you have to know about what are called alternate interior angles. So this is kind of putting two of our words together that we talked about a second ago. So review those words. So alternate means that they're on opposite sides of the transversal. Interior means they're inside the parallel lines. So if we kind of put that together, the alternate interior, well, you've got 3, 4, 5, and 6. Those are the ones that are interior. Now the alternate ones, well, 3 and 4 would technically be alternate, but they form a line, so that is going to be a different story because we've already talked about angles that form a line. Those add up to be 180, so don't think about those as alternate. The alternate ones will be kind of in different spots, so like you're looking from one group of angles to the other. Okay, so like your alternate interior would be on opposite sides of the transversal inside the parallel line. So notice angle 3 and angle 6 are alternate interior. So what do you know about those angles? Well, actually, alternate anything, well, you'll realize are actually going to be congruent. So 3 and 6 would actually have the same measure. So angle 3 will be congruent to angle 6. Okay, that symbol is congruent, so make sure you review your symbols. Okay, so angle 3 and angle 6, like if I told you that angle 3 had a measure of 30 degrees, angle 6 would also have a measure of 30 degrees. And you can kind of look at the angles. They kind of look like they would be the same measure, so you can kind of go off of that too. And then notice you have other angles that are inside the parallel lines. 4 and 5 are also alternate because they're opposite sides of the transversal inside the parallel lines. So angle 4 would actually be congruent to angle 5 because they are alternate interior. Okay, so then alternate exterior angles. Well, still opposite sides of the transversal, this time outside the parallel lines. So outside the parallel lines are my 1, 2, 7, and 8. Alternate would be opposite sides. So like notice 1 is kind of on the left side and 8 is on the right side. So 1 and 8 would be alternate exterior, and then 2 and 7 would be alternate exterior. So what do you have to know about those? Well, I just talked about a second ago, alternate anything will always be congruent. So that means that 2 would actually have the same measure as angle 7. And then 1 would have the same measure as angle 8. So you could say angle 1 is congruent or equal to angle 8. And then angle 2 is congruent or equal to angle 7. Okay? So the last two types of angles that you're going to hear about are when you have same side types of angles. So the first one is same side interior. So these are the angles that are on the same side of the transversal inside the parallel lines. So if we look inside the parallel lines, we've got 3, 4, 5, and 6. We're looking for the ones that are on the same side of the transversal. So like 3 and 5 would be same side interior. And then 4 and 6 would also be same side interior. Okay, so we're going to talk about what do you need to know about those. Well, same side anything will actually always be what's called supplementary. So if you remember from our last video, supplementary means that they add to equal 180 degrees. So if you realize that they're same side interior or same side exterior, then that means you have to add them and then equal them to 180. So like 3 and 5, you would have to add to equal 180. So like to set those up, you'd have to take whatever the measure of angle 3 is, plus the measure of angle 5, and then it would equal 180. Okay, and then same thing, 4 and 6, their measures would have to add to equal 180. Okay, so you'd have to take the measure of angle 4 plus the measure of angle 6 and equal that to 180. Okay, and then the last type of angle is same side exterior. So same side exterior angles would be same side of the transversal outside the parallel lines. So outside the parallel lines were my 1, 2, 7, and 8. So we're looking for the ones that are on the same side of the transversal. So that would be, all right, 1 and 7 are on the same side, and then 2 and 8 are on the same side. Okay, so we're looking at 1 and 7, and then we're looking at 2 and 8. What do we know about those? I had just talked about same side anything will be supplementary. So my same side exterior angles are going to be supplementary, which means that if you know the measure of one of them, you'll know that they have to, the other one, when you add them together, they have to add to equal 180. So that means if you take the measure of angle 1 and you add it to the measure of angle 7, they have to add to be 180. Same thing, if I take angle 2 plus angle 8, that has to add to be 180. Okay, and so if we can write it in symbols, if we take the measure of angle 1 plus the measure of angle 7, that has to add to be 180. And then if we take the measure of angle 2 plus the measure of angle 8, that has to add to be 180. Okay, so when you start setting up equations in a bit, you'll see that will be helpful. All right, so we're going to do just a couple of problems that they could give you that makes you use some of these properties we just talked about. So like one problem you might see is like in number 1 here, it says label all the missing angles, and then they give you one of them. So notice this is that scenario. You've got parallel lines, and then you've got a transversal. Well, think about it. Okay, you've got this group of angles. You got that one, that one, that one, and that one. And then you have this group of angles down here. Okay, so think about how they relate. Because if you know how they relate, it actually makes it easy. Okay, so if you just have to label all of the angles, the first thing that I would suggest is maybe looking for the ones that match up. Look for these corresponding angles because they're going to be congruent, which means that they have the same measure. So if I look, I see that this angle right here is kind of in the bottom right corner of this group of angles. So I'm going to look which one is in the bottom right corner of this, because they would be the same. So notice this angle right here kind of matches up with that one. So that one would actually have the exact same measure. So that one would also be 110 degrees. All right, so then where do we go from there? Well, if you think about to this other video that we talked about, you'll realize that you have two lines crossing. So you could look for your vertical angles, the ones that are opposite each other. And so if you looked at that, you would realize that this one and that one would be the same. If you didn't realize that, then there's other ways to do it. Also, you could look at, remember how I told you to cover up? Do you see how this angle and that angle form a line? These two angles would add to be 180 because angles that form a line add to be 180. So if you kind of think back to that other video, you'd be able to find a lot of these angles real quickly. If not, you could also look for these types of angles. So notice I'm going to look, okay, do I have any alternate interior or alternate exterior angles? Because alternate, really anything will be congruent. So if I look, okay, this angle right here is inside my parallel line, so that would be an interior angle. Which one is alternate interior with that? So alternate interior would be on opposite sides of the transversal inside my parallel line. So this one and this one would actually be alternate interior. Alternate interior angles are congruent. So that means that these two are equal. So this one would have the same measure. And notice these two are vertical angles, so that should make sense. So all of this is going to kind of come back around. Something else. If I look, this one was actually outside of my parallel lines, and then this one is on kind of the right side of my transversal. So if I look for alternate exterior angles, the alternate exterior angle with that would actually be right here, because exterior outside the parallel lines, opposite side of the transversal. So this one and this one would actually be equal. And then notice these are verticals, so you know that that was supposed to be 110 anyway. Okay, so, and the other thing is these are corresponding. So that's another way you could have found out that that one was 110. Okay, so then how do I do the other ones? Well, if you think about some of these other ones, like same side interior angles. So same side interior, interiors inside the parallel lines. And then same side means that they're the same side of the transversal. So like this angle right here and this one are same side interior. Same side interior angles are supplementary. So that means if I take this one and I add it to whatever the measure of that one is, they have to add to be 180. So to find that one, I could take 180 minus 110, and that will tell me what that is. So if I take 180 minus 110, I figure out that that ends up being 70 degrees, okay? And then I can start using, okay, corresponding angles. Which angle matches up with that one? And so that one and that one match up, so I know that that one's 70. And then I can use, okay, opposite angles are equal, or vertical angles are equal, so that means that this one's also 70. And then, well, what would that one be? And there's a couple different reasons that this one would actually also be 70, because notice these are vertical angles, these are corresponding angles, so any way you look at it, that one's 70 degrees. And now you have all your angles labeled, okay? So there's all different ways to use all of this stuff we talked about. You just have to know what do you know about those angles? Okay, so let's do one more. And then we'll work some where you have to actually set up equations, all right? So what if you just had to find two angles? Well, you could look specifically about what you know about those angles, or you could just label all the angles and then you'll find them along the way, okay? I'm going to find specifically these angles. So notice the first thing that I look for, remember I told you it's easy to look for corresponding angles. So the angle that we're given is this one right here. Notice it is turned a little bit, so if you need to turn your paper so that it looks a little bit more normal, you can do that, okay? But notice they will turn them. But if I look, this 40 is kind of in the upper right corner. So if I look over here, that Y is actually in the upper right corner of these. So that Y would actually be the same because they're corresponding angles. So this one would be 40 degrees. And now from here, to find X, I could actually find it a couple different ways. I could find, okay, these two angles, this is our transversal right here. Remember, it's turned sideways. So these two angles are on the same side of it, and they're outside the parallel line. So I could look, okay, same side exterior. I know that they have to be add to be 180. Or you could look, okay, this angle and that angle form a line, and so I know the angles that form a line have to be 180, or add to equal 180. So either way, I know I have to take and add these two, and it has to equal 180. Or you could just take 180 minus this angle right here, minus the 40, and you'll figure out what that one is. So if I take 180 minus 40, I get 140 degrees. So there is X. So X is equal to 140 degrees, and then Y is equal to 40 degrees. So in the next video, we'll be practicing actually writing equations to find variables.